Hey guys, this is Parabolas Day 3, so this is notes for horizontal parabolas. So this will be very different. Obviously a horizontal parabola is not a function. It does not pass the vertical line test, but we are not working in the world of functions in this chapter. We are working in the world of conics. So we will be working with circles, which are not functions, ellipses, which are not functions, hyperbolas are not functions, and neither are horizontal parabolas, so no big deal. The equation will look very similar to a vertical parabola equation, except that it will have an x equals instead of a y equals. So that is how you know that it's a horizontal parabola and not a vertical parabola for now. Actually, we will have lessons on being able to tell which conic is which. But for now, so far, I would just look for x equals. Okay, so that means that the vertex will be backwards. Again, Mrs. Young's video will have this information, so I'm not going to dwell on it. But just notice that the h value will come from the end of the equation and the y value will come from inside the parentheses of the equation. It's opposite of what we were doing before. So you have to be very careful when we mix the problems together to know whether you're working with a vertical or horizontal, because that will determine how you find the vertex and do the rest of the problem. Axis of symmetry is now going to be horizontal. If you think about it, a horizontal parabola will have a horizontal axis of symmetry because the axis of symmetry goes down the middle of the parabola. Okay, so that's why it's y equals, and it'll match the y value of your vertex. If the a value is positive, it's going to open right. If the a value is negative, parabola will open left. You will find the p-value the same way that we found the p-value from the previous problems. However, when we find the focus and the directrix, we will add that p-value to the x value of the vertex, and that's simply because the focus will move to the left or to the right of the vertex instead of up and down. If something's moving up and down, we add to a y value. If something's moving left or right, we add to an x value, and that is the reason why we're going to add that p-value to the x value for these problems rather than the y value. Hope that makes sense. Directrix will just subtract that p-value again from the original x value. 1a, 3a, 5a still works, except instead of going up 1, up 3, up 5, or a multiple of that, we're going to go left 1, left 3, left 5, or a multiple of that, or right. So I'm going to do the first problem with you guys. All right, here we go. This is example 1. Now, right away, be careful. And I tend to work fast, so I do often mess this up. One thing that helps me out is that I kind of try to remember, like, oh, that's my x value. And, of course, the number grouped with the y value is going to be the y value. So my vertex is going to be a positive 4 because this number, that value won't change signs, but the one in the parentheses will. So that's going to be positive 3. 4, 3 is my vertex. Now my a value is negative 2, which means this is going to open left because it is a negative a value. P will be 1 over 4 times a, so 1 over 4 times negative 2 is negative 1/8, or 1 over negative 8. Okay, axis of symmetry. Guys, sometimes I like to kind of draw myself a little sketch because I'm very visual and it helps me remember, oh shoot, my axis of symmetry this time is horizontal, so it's y equals, and it will match the y value of your vertex, so y equals 3. The focus is going to be h plus p. So we're going to take our h value, which is 4. That comes from the x value of the vertex. Add the p-value, so plus negative 1/8. So that is going to be 3 7/8, comma, because the focus is a point, and then it's just going to match your y value of your vertex. That's 3. Next, the directrix, h minus p, will be 4 minus negative 1/8. Minus a negative turns to a plus. So that is going to be x equals 4 1/8. It's x equals because the directrix will be a vertical line, but a trick that I like to use is that it's always the opposite of what the letter of what the axis is. So that's one thing you can think about. All we have left to do is graph. So let's start with the axis of symmetry at y equals 3. And this should be a partial eraser dashed line. Next, I'm going to plot the vertex, which is at 4, 3, and 1A, 3A, 5A. So we're going to go up 1, left 2. Okay, because that A value is 2. So then up 1, left 1, 2, 3, 4, 5, 6. Okay, the reason I went 6 is that 1A, 3A, 5A formula. So that's going to go left 2, left 6, left 10. Obviously, that left 10 won't fit. So then this will be mirrored. And we have our beautiful left-facing parabola. Oops. Last, we find the focus and directrix. Focus was at 3 and 7/8, 3. So that's just really close to 4. Again, that focus should always be inside the parabola, and the directrix should be behind the parabola. So that is going to be at 4 and an 1/8. And obviously, I'm not going to take out a ruler and measure 1/8. So I'm just going to eyeball it. It should just be really close to 4. And that should also be dashed. Okay, so that's it, guys. That's all there is to it. Practice, practice, practice.